Hello, and welcome to the session on volume of compound cuboids. The three things that we are going to learn in this lesson are: first, we'll understand what are compound cuboids. Then we'll try and find out how do we split compound cuboids into normal cuboids. And finally, we'll try and find out which are the two different ways in which we can find the volume of any compound cuboid. Let's get started then. So what are the prerequisites for this particular lesson? Two things, namely, first, you need to understand what are compound cuboids. So compound cuboids are 3D shapes which are formed by combining two or more cuboids. Like as you can see, the three shapes that you can see here, okay, like in the first case, that left top one, that shape can be formed by combining two different cuboids. Did you realize that? The other two shapes can be formed by combining three different cuboids. So these shapes are called compound cuboids because they have been formed by combining two or more cuboids. That's the first requisite, okay, that you need to understand what are compound cuboids. The second prerequisite is that you should know how to find the volume of a prism. This has been covered in one of the lessons prior to this. As you know, prisms are 3D shapes which have the same cross sections along one dimension, right? Like in this case, it's a hexagonal prism because the cross section, which is the hexagon, remains same throughout the height of the prism, correct? And how do you find the volume of any prism? It is basically the area of the cross section, which is the cross section which remains same throughout. So you find area of that particular shape and you multiply by the height. And the height of a prism is nothing but that dimension along which the cross section remains the same. With these two knowledge, we can now go and find out how to go about finding the volume of any compound cuboid. Let's take the first example then. Let's look at this L-shaped figure. As you can see, it has been formed by combining two cuboids. So let us first find out which is the first way of finding the volume of such a compound cuboid. The first method is to go about finding the volume using the rule of Prism. So as you can see, the compound cuboid in this case is nothing but a prism with the L-shaped cross section remaining same throughout the depth of the prism, which is the 20 centimeters dimension, as you can see, right? So we can always find the area of this L-shaped cross section, multiply it by the depth, which is 20 centimeters, and you can find the volume of this particular compound cuboid, correct? So let's first go about finding the area of this L-shaped figure, which itself is a compound shape, which is formed by two rectangles. Do we know all the dimensions to find the area of this particular compound shape? Not really. Okay, there's one dimension which we don't know, which is the width of the vertical rectangle. So let's try and find out how do we go about finding the area of this cross section, correct? So there you go. That's the cross section. As I said, we don't know the width of the top portion, correct? How do we go about doing this then? We first divide this particular L shape into two rectangles. If I look at the base rectangle, the length of that rectangle is 18 centimeters. Whereas on top, one of those dimensions is 10 centimeters, the one to the left. So the one to the right will be 8 centimeters, which gives us the missing dimension, right? The width of the vertical rectangle. And now with this, we can find the area of this particular compound shape. For that, we need to divide this rectangle into two. Let's first find the area of the smaller rectangle, which is the one on the left. That, as you can see, has a length of 10 centimeters and a width of 5 centimeters. So the area of that rectangle would be 50 centimeters squared. Whereas the one on the right the length is 16 centimeters and the and the width is 8 centimeters. So the area of that rectangle is 128 centimeters squared. So this one has an area of 128 centimeters squared, whereas the other one, as I said earlier, it's 10 centimeters times 5 centimeters. So it is 50 centimeters squared. So together, this L-shaped figure has an area of 178 centimeters squared, 128 plus 50. So we have found out the area of the cross section for this particular prism. All I need to do is multiply this area by the height of the prism, which we had already established earlier is that dimension along which this L-shaped cross section remains the same throughout, which is the dimension with a length of 20 centimeters. Correct? So we need to multiply 178 by 20 to arrive at the area of the compound cuboid, which is nothing but 3,560 centimeter cube. Right? This was a more conventional or a traditional way of finding the volume of a compound cuboid, where you find the area of the cross section, multiply it by the height of the prism, and there you go, you find the volume of the prism. In this case, we have treated the compound cuboid as a prism with a L-shaped cross section. What's the other method then? Well, the other method is in which we split this particular compound cuboid into two different cuboids. Let's have a look. So first of all, let us find out whether we know all the dimensions for both the cuboids. Actually, we don't know, okay, that little dimension, which is the height of the vertical cuboid. So for that, what we do is we find this particular height. That height is 16 centimeters, of which the width at the bottom, okay, is 5 centimeters. So the width on top would be 11 centimeters. And now I believe we have all the dimensions which are required. So how do we go about finding the volume of this particular compound cuboid then? We split this into two different cuboids, something like this, right? Now, as you can see, there are two distinct cuboids, one with red color and the other which has been marked with the blue color. We can split this into two. As you can see, the dimensions of each of these cuboids are given as below, right? You can always compare it with the original diagram in case you didn't understand how did we arrive at these dimensions. Well, now that we know the dimensions of each of these cuboids, we can always find the volume of individual cuboids and then add them to find the volume of the compound cuboid. Do you know how do we calculate volume of any cuboid? Yes, it's length times width times height. So for the red colored cuboid, the volume will be 20 times 11 times 8, which is 1,760 centimeter cube. How about the other one? The cuboid with blue edges will have a volume of 20 times 18 times 5, which is equal to 1,800 centimeter cube. So together, both of them combined will have a volume of 3,560 centimeter cube. If you remember, this was the same volume that we had obtained earlier, wherein we had treated this particular shape as a prism, right? So ideally, you should end up getting the same answer, whichever method you use. Do you remember? We use two methods. First method wherein we treat the compound cuboid as a prism. Okay, in this case, a prism with a L-shaped cross section. And second, where we actually split up the compound cuboid into two separate cuboids. You can choose to use whichever method which you feel convenient, right? Let's take one more example and understand both of these methods once again. Well, in this case, we have a compound cuboid which has the shape of a T. Let's use the first method to find the volume of this particular compound cuboid. Can you recognize which of the cross section is the same throughout one of the dimension? No points for guessing. Okay, it's the T-shaped cross section, which remains same throughout the height, as you can see. which means if I were to treat this as a prism, then the base of the prism would be the T shape, and the height of the prism will be the height of this particular shape, which is 10 centimeters, as you can see. Right? So let's go with the first method, wherein we treat this shape as a prism with the cross section T remaining same throughout the height. So let's find the area of the cross section, which is the base, and multiply it by the height of the prism, which is 10 centimeters. So how do we find the area of the T shape? As you can see, the T shape has the given dimensions. You can again compare the shape with the original shape and figure out whether we have put the right dimensions in. Now, do we have enough information to find the area of both the rectangles? Yes, we have. So let's first split this into two rectangles, one on top and one at the bottom. The area of the rectangle on top is 34 times 10, which is 340 centimeters squared. On the other hand, the area of the rectangle at the bottom is 10 times 24, which is 240 centimeters squared. So together, both of them will have a area of 340 plus 240, which is 580 centimeters squared. Now that's the area of the cross section. Remember, the cross section is T for this particular prism. So the area of the cross section is 580 centimeters squared. To find the volume of the prism now, we need to multiply it by the height of the prism, which we had established was the 10 centimeters dimension, the vertical distance of 10 centimeters. So if I multiply that by 10 centimeters, we'll get the volume of this particular compound cuboid, which is 5,800 centimeter cube. Well, that was the first method in which we treated this particular compound cuboid like a prism with a T-shaped cross section. Let's now move on to the second method. Remember, the second method was we split this particular compound cuboid into two different cuboids. And we can clearly establish that, right? One of the cuboids is horizontal and the other one is placed vertical right in the middle. So can we split this into two different cuboids? Yes, we can. As you can see, one of them has been highlighted with red outline and the other one with a blue outline. If I split both of these cuboids separately, here are the dimensions of each of these cuboids. Once again, my suggestion is you compare these two with the original shape and figure out whether we have put the right dimensions in each of these cuboids. Yes, we have, right? What is the volume of the cuboid with the red outline? Remember, volume is length times width times height. So in this case, the volume would be 34 times 10 times 10, which is 3,400 centimeter cube. What about the volume of the cuboid with blue outline? It will be 24 times 10 times 10, which is the same as 2,400 centimeter cube. And the volume of the compound cuboid will be the addition of the volumes of each of these cuboids, which is nothing but 3,400 plus 2,400, which is equals 5,800 centimeter cube. Once again, you can check. This is the same answer that we had obtained when we found the volume using the original method, okay, wherein we treated this as a prism with a T shape. So we have learned two different methods of finding volume of compound cuboids. One, where we treat compound cuboids as a normal prism. We find the area of the cross section multiplied by the height. And the second method in which we split the compound cuboids into two or more different cuboids and then find the volume of each of these individual cuboids and add them, right? Now you can use whichever method you find suitable into these exercises. There are 8 questions in all. The first 6 questions have compound cuboids which are made by joining two cuboids. And in the challenge question, we have the H and the U-shaped compound cuboids, which have been formed by joining 3 different cuboids. Let's see how many of you can get onto the challenge questions. Well, That's the end of this particular lesson, in which we learned how to calculate the volume of compound cuboids. The three things that we learned in this case are: first, what really are compound cuboids? Second, how do you split any compound cuboids into individual cuboids? And three, which are the two different methods of finding the volume of any compound cuboid? Remember, the first method is in which we treat the compound cuboid as a normal prism, and we then find out the area of the cross section, multiply that by the height. And the second method is where we split the compound cuboids into two different cuboids and then find the volume of each of these individual cuboids and add them. I hope you understood the concepts that were taught in this particular lesson. Thank you.